Okay, good afternoon, everyone. I'm Carlo,
And I'm Pat.
and we're Mission Impossible. And today we'll be discussing the analysis and adoption prediction of stray cats and dogs. Okay, so I know a lot of us haven't been having a good 2020, but just so you know, it's the same for our animal friends. Um, just a recap, in the first quarter of 2020, when Taal volcano erupted, organizations such as Kara, PETA, and POS have been distributing pet food as well as conducting rescues of affected animals. But in the second quarter, as the pandemic started to pick up, the lockdown measures affected the efficiency of these welfare groups due to first, diminished mobility due to lack of transportation and established checkpoints. Second, more expensive pet food and medicines, especially since some of the volunteers might have lost their income. And lastly, the closure of essential services like vet clinics for animals who might need them. In terms of the general handling of strays in the Philippines, we have the fourth largest number of deaths due to rabies. And if animal pounds of the LGUs get to these animals, they opt to dispose of said animals after a certain number of days. So welfare groups can mean the difference between life and death for these strays. And speaking of welfare groups, we tried to get some data from our local organizations, but sadly we didn't get any replies. So we looked to our neighbor Malaysia and got our data from Pet Finder, which is their version of an online classified ads for strays, and got their gaggle competition dataset. Moving on, the study that we will be conducting will be first for welfare groups, second for those who want to build a similar Pet Finder here in the Philippines, but lastly, this is for my baby girl, Hoy Hoy, and all the strays who have been relying on humans who have suddenly vanished during the pandemic. With this study, I hope we can save more of our furry friends. Okay, so let's see what makes animals adoptable. So, just an overview. There are more dogs than cats in the dataset we found. In terms of adoption speed, cats are adopted slightly faster. If you look to the legend on the right, the scale goes from 0 to 4, with 0 being the fastest and 4 being the slowest. Looking at the breeds of the animals, pure breeds are adopted faster than mixed breeds. And in terms of rescuers, top 15 rescuers account for 15% of total animals in the dataset. And they also have an 85% adoption rate. In terms of animal age, most are puppies and kittens below a year old. And when we look at the adoption speed, these puppies and kittens are adopted faster on average. Okay, for user descriptions, the most common bigrams are for contact details and age of the pet, both for dogs and cats. Okay, now for our model, I turn you over to Patrick.
All right, cool. Thanks, Carlo. Now, in terms of our model, we would just like to reiterate that our data is sourced from a Kaggle competition. And we wanted to build a machine learning model that's capable of predicting the adoption speed of the listed cats and dogs. Thankfully, all the data in the dataset were already labeled based on just how fast the animals were adopted upon being listed on the platform. If you look at the legend over here, you can see that a label of 0 would mean that the animals were adopted the same day that they were listed, while a label of 1 would indicate that the animals were adopted within 1 day to 1 week upon being listed, and so on and so forth. In terms of our model performance, we measured our model performance through the quadratic weighted KAPPA metric. Now, you guys might be wondering, what is the KAPPA score metric and why didn't we use something more known like accuracy? Well, the KAPPA score metric is a statistic that is used to measure inter-rater reliability for categorical items. Its main advantage is that it takes into account the possibility of the agreement occurring by chance. If you look at the table over here, the kappa score is generally a value from 0 to 1, with a value of 0 being an agreement due to purely by chance, and a value close to 1 being an almost perfect agreement without taking into account uh, randomness. So the top kappa score for this competition, achieved by other data scientists all over the world, is 0.45. And this is the standard that we are trying to achieve as well with our model. Now, what were the features used by our model? Let's look at Simba over here. Now, we want to know just how fast Simba can be adopted upon being listed on the website. Well, our model almost used almost all of these features. Specifically, the number of listings that the animal's rescuer have, basic animal profile info, including animal breed, sex, and age, some health-related information, some physical descriptives, including animal size, fur length, and color, and even the state where the listing is located, and also whether or not there is an adoption fee. But that's not all. Our model also incorporated text data in the form of the rescuer-generated descriptions of the animals, as well as the photos that the rescuer posted of the animals being put up for adoption. In terms of our model, we used an XGBoost classification algorithm, and in order to build the training data frame, we used the aforementioned listing features we discussed from the previous slides. And then, in order to make more sense of the images, we passed them over a pre-trained Keras dense neural network, and then passed them through a truncated SVD algorithm for dimensionality reduction. And then for the description, in order to gain more insights, or rather more value from them, we took their TF-IDF transforms, and those features were dimensionally reduced using a truncated SVD, and then we also incorporated that into the training data frame. Now, what were our modeling results? Again, we were aiming for a kappa score which is close to 0.45. And what we got was 0.42, which in hindsight, we guess is close enough. But more than that, in order to gain a better understanding of the model, we also plotted the top 10 features that affected or contributed the most to its performance. Looking at the bar graph, we can see that age was the main contributing factor to predicting adoption speed, followed by the number of listings of the rescuer, and then the animal breed. Now, the remaining 7 of the top 10 features were all related to the descriptions and also the images posted. Now, you guys might be asking, what was the point of building a machine learning model? Well, the ML model is a proof of concept that predicting animal adoption speeds using AI tools is possible, and certain factors contribute better to this prediction. And aside from animal age and breed, rescuer reputation also plays a huge factor in predicting how fast an animal is adopted. And lastly, some user-controlled contributing factors to adoption speed are listing descriptions and listed photos. And now let me hand you guys over back to Carlo to wrap things up.
Okay. Thanks, Pat. So for our recommendations, first, there is a vacancy for an online adoption platform for those who might want to make one. And for the future of our model, we can include an automated animal adoptability rater. And to act on our strongest features for animal age and animal breed, we can give emphasis to older animals and mixed breeds on adoption platforms as they tend to go unadopted. In terms of rescuer ID, we can highlight the profiles of trusted rescuers to make their jobs easier and to give them recognition. And lastly, for those who can, you can help our local organizations through the links below. And with that, from me, Patrick, and Hoy Hoy, thank you for listening to our presentation.